we looked at in the last one using our chapter 1 transformation, we looked at what happens with A and B. So in this case here, we're going to look at H and K. Now in trigonometry, we just changed the letters. They changed their letters. They have their own letters. So H becomes C and K becomes D. I don't have a good reason on why we changed those parameters, but that's what happens. And they all have their own special name. So remember A, the special name for A was amplitude. B didn't have its special name. So H we know is the horizontal translation, but in trigonometry we call it a phase shift. And K is my vertical translation, and in trigonometry we call it a displacement. So trigonometry is the one unit that they have their special names. So we're going to go through 5.2 and we're going to do the same thing we did in 5.1, coming up with what does C do, what does D do? Does it change in terms of what we already know about C and D or H and K? Okay, so let's look at the graphs of sine x minus c. So I have my base graph in blue there of sine x. I have my red graph, which is x minus pi over 2, and my green graph of x plus pi over 2. So let's use what we know about chapter 1. In chapter 1, because it's in the brackets, I know horizontal lies. So let's see if it follows the same pattern. Since it's x minus pi over 2, I should expect to see it go pi over 2 to the right. So let's check. Here's my base graph. If I move pi over 2 to the right, I do get the red graph. So it looks like it works. This one here, x plus pi over 2 from chapter 1, that would say that it moves pi over 2 to the left. So my base graph in blue moved to the left. I get pi over 2. It does in fact work. So since I'm shifting it left and right, that's not affecting the domain. It's also not affecting the range because that's a vertical quantity, as is the amplitude. Let's look at period. So I can see here one hill, one valley is the same as one hill, one valley. They're all the same horizontally. It's not been stretched because remember, the only way I affect my period is if I horizontally stretch it. So my period is also going to be the same. So if all of those things are the same, what's the thing that's different? Well, if I look at this, the thing that's different is the starting point. See how this is where I'm supposed to start? But here's where I'm starting for the red graph. Here's where I'm starting for the green graph. Also, it looks like all of the x-intercepts have changed as well. So let's look at what the x-intercepts were supposed to be. So they're supposed to be negative 2 pi, negative pi, 0 pi, and 2 pi. So when I look at the minus, we said it moved to the right, I can just add on pi over 2 to each of these. So if I add on pi over 2, I get negative 3 pi over 2. If I add on pi over 2 to negative pi, I get negative pi over 2. Let's look at the green graph. That one, because it was plus pi over 2, is moving to the left, which means all the x-intercepts will move to the left. Let's check those. So 0 minus pi over 2, yep. Pi over 2 minus pi over 2, and 2 pi minus pi over 2, 3 pi over 2. So it looks like that works. Now, when we first introduced the idea of sine and cosine, remember that the only difference between sine and cosine was the starting point, and it's actually just a shift. So by shifting the sine graph pi over 2 left or right, we actually get the cosine graph. So the only difference between sine and cosine is the starting point. Okay, let's see if the same thing is true for cosine. So we're going to look at the cosine graph now and see if all of those rules follow as well. So when I see my base graph here in blue and I have x minus pi over 2, I should expect to see my graph moving pi over 2 to the right. So you can see, yes, that did in fact work. For here, when I have x plus pi over 2, I should expect my graph move pi over 2 to the left. And you can see that, yes, that also worked. So similar to sine, none of these are going to be changed. It's just going to be the x-intercepts and the starting point. So let's look at the x-intercepts again. So the x-intercepts for cosine here are going to be changed in the same way they were for sine. If I go pi over 2 to the right, I'm going to add pi over 2 to each of these. So negative 3 pi over 2 plus pi over 2 is negative pi. Negative pi over 2 plus pi over 2 is 0. Let's see if it also works on the other way, if I subtract when I'm moving left. So if I have pi over 2 and I subtract pi over 2, you can see, yes, I get pi, or 0, sorry. And when I subtract pi over 2, I also get pi. So it looks like that's working. So let's put this together, the effects of C. So it looks like it changes the start point, and because it's moving the entire graph left and right, it also changes the x and the y intercepts. That horizontal translation has a special name called the phase shift. So the phase shift is right if C is positive, it's left if C is negative. So to find your C value, just like in chapter 1, make sure B is factored. And remember, horizontal lies like Pinocchio. So whenever I have something inside the brackets, I know it's horizontal and it's a liar. Okay, let's look at this question here. So we have sine x and we have sine x plus 90. Let's talk about what's happening here. This is a horizontal translation, 90 degrees to the left. That's how we would answer in chapter 1. But in trigonometry, let's use the new word, which is phase shift. So therefore, I can say there is a phase shift 90 degrees left. Okay, and the next one, I have x minus pi, so I know that that would be a horizontal translation of pi units to the right. But let's use the trig term, which is phase shift. So therefore, I can say that there is a phase shift pi units to the right. Okay, let's look at now our D value and see what's going on with D. Okay, so with D value, remember in chapter 1, that was our vertical translation, and it looks like that's happening as well. So vertical should affect anything on the Y values. So you can see the base graph here of, in blue, cos x. When I have cos x plus 1, look, it went up 1 unit. When I have cos x minus 1, it went down 1 unit. So it behaves the same way that we were really expecting to see. So because this is vertical, it affects anything that is vertical, meaning it's going to only affect the range. Okay, so the range, when I go up 1, well, I'm going to go from negative 1 up 1 to 0. I'm going to go from 1 up 1 to 2, 0 to 2. Okay, the amplitude doesn't change. The amplitude is really the height of the graph, so I'm not vertically stretching it. That's what affects the amplitude. The domain and the period are also not affected because those are not vertical quantities. So it looks like just the range is affected in this table. So if I have cos x minus 1, I'm going to take the low point of negative 1, go down 1 to negative 2. The high point of 1, go down 1 to be 0. And then those quantities remain unchanged. So the only thing that's different is the range. Let's see if that's true for the sine graph as well. So here's my sine graph, and it looks like everything's the same here. Plus 1 going up 1, minus 1 going down 1. So all of these quantities here, because they are not vertical, stay the same. What's changing is the range. So going up 1, I add 1 to each of these values. Going down 1, I subtract 1 from each of these values. So let's put it all together, the effects of D. So D changes the y-intercepts, the x-intercepts, the range, and the midline. Midline is your average line, your halfway point of the graph. So a vertical translation from chapter 1 in this chapter is called a vertical displacement. We're going up if it's positive, down if it's negative. So just like A, we can use a formula for D value. So D is max plus min divided by 2 because it is an average. So to find D, make sure Y is isolated. And remember, anything vertical is just straight up honest, exactly like I would expect. So let's try this one here. So compared to cos x, what transformations have occurred? So here my D value is negative 2. So I know that that means a vertical translation of 2 units down. But let's use the trig term. Therefore, I can say there is a vertical displacement 2 down. This one here, I have cos x plus 3, so that means a vertical translation of 3 up. But using the trig term, that is a vertical displacement of 3 up. Okay, let's try another one here. Describe all the changes that have occurred compared to y equals cos x. So first thing I notice, well, there's actually two things I notice. Y is not isolated, b is not factored. So remember from chapter 1, we always want to factor b and isolate y. So if I add 4 to both sides, I'm going to have negative 2 cos, we'll figure all that out, plus 4. So add 4 to both sides first. Then I'm going to factor 3 from inside my brackets. And I'll end up with that. Okay, so now I can do all of my descriptions. So R stands for vertical reflection or horizontal reflection. I can see since A is negative, I have a vertical reflection. Remember our RISA here, we reflect in, so a vertical reflection in the x-axis. Okay, B is not negative, so I don't have a horizontal reflection. Okay, let's look at stretches. So a value of 2 means I have a vertical stretch. Now remember, using our RISA, vertical stretches are about. So I have a vertical stretch by a factor of 2. And that will be about the y-axis. Sorry, the x-axis for vertical. Okay, horizontal. I see I have a b value, but remember horizontal lies, so it's actually going to be a horizontal stretch by a factor of not 3. Oh, I forgot to write my stretch factor here. 2. Whoops-a-daisy. Okay, so this one here is not going to be of 3. It's going to be a horizontal stretch by a factor of 1/3, and that will be about the y-axis. And last thing, T stands for translation. So looking at horizontal, I have a horizontal translation of pi over 6 right, and I have a vertical translation of 4 units up. But let's use our words for trigonometry. So what that really means is that I'm going to have a phase shift, pi over 6 right, and a vertical displacement of 4 units up. And that would describe everything that I need. So again, remember to factor B, isolate Y. Let's try another one. So transformation, this time we're going to describe the transformation and have to find the equation. So transformation of sine x has made the following changes. So I have an amplitude of 4. I know that's my A value. A period of 3. So I can use my period to figure out my B value. So remember, B value is 2 pi is always on top. 2 pi divided by the period, which the pi's cancel, is just 2/3. A phase shift of half a pi to the right. So that means that C is just pi over 2. And a vertical displacement down 6, which means D is negative 6. So putting that all together, this is 5.1 and 5.2 all together in one question. For sine of B, x minus pi over 2 minus 6. That would be my final equation. Okay, let's look at another one here. So this one here, I have a sine graph, and it's giving us a max and a min point. I want to determine the equation of the curve. So to find the equation, we just have to find the parameters A, B, C, and D. So whenever I do these, I always start with A and D first. So I'm given that the maximum occurs at 12.4. Sorry, the maximum is 12.4 and the minimum is negative 2.2. So I can use those formulas that I have for A and D to figure that out. So A is max minus min divided by 2, which I see is 7.3. And D is the average, which is max plus min divided by 2, which I see is 5.1. So I always start with A and D first. Now I'm going to move on to B. Now remember, B is not the period, but I use it to find the period. So I have to find the period first, and there's 3 different things I can look for. First of all, I can look at how long it takes to go through one full cycle. So that could be a hill and a valley, max to max, min to min. That would be a full period. So you can either find the full period, or If we have max to min or min to max, that's half of the period. So I would take half of the period multiplied by 2 and get the full period. Or I can go to my quadrants, my quarters, max to midline or max to midline or min to midline, there we are, is a quarter of the period. So if I times that by 4, I would get the full period. So in our question, we have a max point and a min point. Max to min is half of the graph. So to find b, we just have to find the period first. So looking at the period, the distance between negative pi over 6 and pi over 3. So I'm going pi over 6 to the left. Don't worry about the signs. The sign just tells me left and right. And I go pi over 3 to the right. So to add those, I just really need a common denominator. So instead of pi over 3, I'll call this 2 pi over 6. So adding those together is 3 pi's over 6, which is just pi over 2. So the distance between those is pi over 2. But that is only half of the cycle. So I have to take that and times it by 2 to get the full cycle, which is just pi. So now that I know the period is pi, I can figure out what my b value is, because b value is 2 pi. 2 pi is always on top, divided by the period. Pi's cancel, and b is 2. So now we have a, b, and d. So all that's left is c. Now C is a little tricky, but I think I've come up with a really good way to help you figure out C in an easy way. C is the x-coordinate of the starting point. So this is where in 5.1 I said the starting point is so important to know. So cosine always starts at a max or a min. If it starts in a max, that's above the x-axis, A is positive. So when A is positive, the C value would be the x-coordinate of the max point. Or if I have a minimum, if it starts at a minimum, A would be negative and C would be the x-coordinate of the min point. That's for cosine. Let's look at sine. Sine always starts at the midline. So if I start at the midline on an upswing, that's positive. So A is positive when I'm midline upswing. So the x-coordinate is going to be the average. So C is the average of the x-coordinate for min and x-coordinate for max, because it's right in the middle. Now, if I start midline on a downswing, down is negative. So A would be negative. Midline on a downswing, C is going to be the average of the x-coordinate for max and the x-coordinate for min. So C really is an average. Hey, wait a minute. Did the math teacher just call me average? That's so mean. Well, good way for you to figure it out. Or remember it. C is average. So now let's go back to our graph and figure out which way it is. Okay, what C value are we going to use? So when I have a sine equation, if I ask you for a sinusoidal equation, that's not just a sine equation. That could be sine or cosine, because remember, the only difference between those is the starting point. So let's find both equations just for fun. So cosine. So since I have a max point that is closer than the min point. See how the max point is over just pi over 6 to the left? The min point is pi over 3, which is 2 pi over 6 to the right. So the max point is actually closer. So since we're going to use a max point, A stays positive because it's maximum, positive for max, negative for min. So C is going to be the x-coordinate of that max point, so it's going to be negative pi over 6. So putting that together with A value, D value, and B value that we already have, we can put that all together for my cosine equation. So cosine will be 7.3 cosine of B x minus C. So minusing a negative is actually adding a positive. Oops, pi over 6. And then plus my D value of 5.1. Okay, let's look at sine. Now, sine is the average between max and min. So if you look at the points, they're going from max to min. So we're going max to min. The midline obviously is right in the middle. So since we're starting, if you think about max, min, and the midline is right in between. Sine starts on the midline, but you can see I'm going midline on a downswing. So since I'm going midline on a downswing, we're going to make a negative. And then C is just the average of the x coordinates for the max and the min. So my max x coordinate is negative pi over 6. And I'll add that to my x coordinate of my min point, pi over 3. And then I'll divide those by 2. So if you put those into your calculator, just take pi out and put pi back. I would go negative 1 over 6 plus 1 over 3 divided by 2, and you're going to get 1 over 12, and then throw pi back in. So remember, take pi out, put pi back. Okay, so let's put it all together. Now remember, we made a negative, so it's negative 7.3 sine of b, which is 2. X, now it's pi over 2, so it's just going to be minus pi over, 12, not 2. And then add 5.1. And that would be my equation. Okay, so let's summarize this all together. The C value is called horizontal phase shift. To find the C value, you want to look at the x coordinate of the starting point. So remember, sine starts on the midline. If it's midline on an upswing, A is positive. If it's midline on a downswing, A is negative. Cosine starts at a max or a min. Max or a min. So if it's at a maximum, it's going down. Maximum, it's high. That's good, which is positive. Minimum is low, which means A is negative. Your D value is called your vertical displacement, and it's found by adding max and min y values dividing by 2.